Hey there, digital makers. Welcome to this week's Raspberry Pi Foundation stream for digital making at home. I'm Mr. C, coming to you from Cambridge in the United Kingdom. It's great to see so many people logging onto all the different platforms that we're casting to this week. So whatever platform you're watching us on this week, remember that you can communicate with us on the stream by just typing things into the comments and hitting enter. If you're watching on the rpf.io/home website, then the best way to communicate with us would be to click through to the YouTube site and you can comment there and you can get through to us and we can have your questions pop up on the stream if they come through. We've got some really, really special guests this week, two special guests, in fact. The first one who I'll bring on in just a minute is the CEO of Raspberry Pi himself, Eben Upton, co-creator of the Raspberry Pi, an amazing piece of kit. I'm sure all of you are here because you love the machine a lot. And so we'll have a few words with him. And then we've got another really special guest who's Ed from Manchester. And he's the guy who invented our project for last week's stream. So we thought we'd get him on this week and he could show us another amazing thing that he's made at home. And he's going to talk me through how to build his incredible project. So stick with us, guys. We'll do some coding in a little bit. But first off, we'll start up with an interview with Eben. So Eben, are you there?
I am here.
Awesome. How's it going, Skipper? You all right?
I'm there. None of us are here, right? Everyone is there.
So. That's true. Everyone's there. We're all in different places, but we're all over there. Are you in Cambridge at the minute then?
Yeah, I'm in Cambridge. I'm in Cambridge at the Raspberry Pi trading offices.
Awesome. Oh,
Raspberry
cool.
Pi trading offices.
Yeah, the tumbleweeds are rolling through the halls, I imagine, at the moment.
You'll see one going down. If I open this door, you'll see them going down the hall about 1 every day.
Awesome, that's cool. And so we're doing this as a digital making at home stream. I'm really glad you could come on. It's amazing that you can share some time with us. I know how busy you are at the moment. Everything's kicking off with the new Pi that's been launched and stuff like that.
Yeah, I'm the new baby.
So the new baby too.
Yes, I have a 4-week-old baby. So it dwarfs any kind of Pi related busyness gets dwarfed by baby business.
I can imagine it's coming for me. I'm at the last couple of months of that. I'm waiting for my new baby to be coming in sort of September. So it's all about to kick off for me as well. Any tips? Any pro tips, boss?
Make the most of the next few months. if you like sleeping, make the most of the next few months.
I do like sleeping. I'll get as much in as I can. But yeah, so like we do a lot of stuff about digital making at home here. And like, I know if you're the same as me, like back in the day when we started doing stuff, it was all done at home, right? Like there weren't so many classes. There weren't clubs that you could go to. I taught myself, my old man helped me learn in my bedroom. How did you get started in coding and then all the way up to the top of Raspberry Pi?
Well, I had a friend when I was about 9, I think, called Martin Brown. And Martin Brown had a computer at home called Nacon Electron. That he could program, and he could do those simple little basic programs where we, print what is your name, input $n$, print hello $n$. And he could do these things and build kind of reasonably complicated little interactive programs that way. And it was just infuriating that my friend could do a thing that I couldn't do. And so I started learning to program on the BBC Micro, which I guess a lot of people have our kind of vintage have some experience of this kind of these BBC machines that were kind of ubiquitous in education during the 80s and part of the 90s. And they just sat there in the corner. And as you say, there wasn't really a system of teaching people to program at schools. So these things sat there, and although they were programmable computers, they were often used to run application software. So they were being used to teach English, run an English teaching program, run a French teaching program, run a maths program. But they were programmable computers, and I started programming them in lunchtime, break time, after school. Bought one myself, so I bought a very beaten up old BBC Micro. You had to hit it to make it boot up. So if you hit it on the top of the power supply and then flick the power switch within a second while something was still vibrating inside the case, it would turn on. And that was my beeb, and I had that for many years, and I loved it. And I programmed in BASIC, and then in assembly language, 652 assembly language. And then I got a Commodore Amiga. So I was I was one of those kind of classic kind of home 1980s, 1990s home hobbyist programmers. It's kind of fun because when we started Raspberry Pi, we idolized the 1980s in a lot of ways because that's when a lot of us were involved in computers and that was our experience of it. But when you look back at the 1980s, it really, compared to today, it was kind of a terrible environment to learn to program, right? Because there were no lessons in schools, and the hardware wasn't very powerful, and there was no internet, so you couldn't ask people questions. You get stuck these days. You can come on forums, or on any one of a vast number of other platforms, and ask questions and get an answer. And the closest we had to that was the lending library. I remember going through microfiche. Remember microfiche readers in the local lending library, looking up programming textbooks. And then doing an interlibrary loan request in order to get a book about graphics programming. So So yeah, it was a great time to learn to program, but it was also a time that I think put a lot of barriers in the way, and that was reflected in the fact that ultimately, even this kind of glory era of learning to program, maybe only 1 or 2% of people actually do.
Yeah, that's really true. I remember the monthly magazines with the code in the back that you would copy out and then have to debug yourself, like from scratch, knowing almost nothing about what you'd done. All those sorts of like hurdles.
The type in listing is kind of this kind of totemic thing. And of course, we did a book. We did a book last year, Code of the Classics, which is kind of our version of what we think type in listings could look like today in Python. But yeah, they were great. And of course, as you say, the things you got wrong when you were typing them in were kind of pretty much as important as the stuff you got right, because that's how you learn.
Yeah, and I think that's rubbed off in my mindset today as well. The way I think about things is I focus a lot more on the errors and where I went wrong and learn from my errors. And I think that's something the technology industry has picked up on and understands. You know, the fail faster ideal is coming through, and we try to get that to the kids here as well. Like, I mean, talking about that, like in the sense that we had all these old magazines, and the way you and I did things, there were a lot of hurdles, there were a lot of things to overcome, and that sort of gave us grit and determination. I mean, what is different for kids who are starting today, like the kids who are watching now?
So a negative and then a positive. So the negative is computers are much friendlier. That's kind of a positive in a lot of ways, right? If you wanted to just use a computer as an appliance, computers are a lot simpler. So if you want to edit a document on it, much easier to do that on your PC or Mac than what's back on the PC Micro. But what it does mean is that there's a layer of kind of polish between you and the platform. Really, what we were trying to do by making Raspberry Pi was to make a device which let you get through. Still have the polish, because I think you've got to have the polish, but let you get through. So this is a device where, by a PC, and you want to learn to program, you've got to go and get a copy of Scratch. You've got to go out and get a copy of Python. It's very simple. It'll only take you 5 minutes, but that's a material barrier. So really, the dream with Raspberry Pi was make a general purpose computer, but make sure we bundle it with all of the tools you need and surround it with the ecosystem of support that you need. So that's kind of the negative, is that modern computers are very polished, and that can be a barrier. The positive, as I say, is that the online world creates an opportunity to get help from outside your immediate physical neighborhood. Obviously, getting help from outside your immediate physical neighborhood is extremely important over the last 2 or 3 months, because you have no physical neighborhood. But you can get help outside your local physical neighborhood. It also gives you an audience. I used to go to a computer club. I grew up in a town called Ilkley, and there was Ilkley Computer Club every other Friday night, 7:30 till 9:30. A friend of the family can pick me up, take me along with my BBC in a box, set it up, show people what I've done, and the audience is extremely important. So I think that's probably the biggest positive for me. If you make something great, then you can, like Ed's done, you can get it out there, and hundreds, thousands of people can see it. Where maybe when we were doing stuff, you were lucky if 2 or 3 people saw it.
Yeah, and that's really true. I mean, like, that's our theme this week, is sort of like make art with code and like go out and make something that's aesthetically incredible. Are there any sort of creative uses of technology you've seen recently that you admire particularly? Anything you think was really cool?
When I was at university, I knew a guy called Alex Evans, who had worked for a company called Bullfrog, who wrote a game called Populous, which is very popular. And he went on to found a company called Media Molecule, who bought by Sony, and they made Little Big Planet, which is kind of a computer game, but is also a computer game about making computer games. And they've recently released a thing for the PlayStation 4 called Dreams, which is kind of Little Big Planet on steroids. It's an amazing environment for artistic expression, really. It's sort of trying to make it, simplify as much of the programming side of the world as possible. Provide very, very powerful tools to allow people to express themselves through the medium of games, or really through the medium of kind of graphical experiences rendered on these incredibly powerful platforms. So yeah, Dreams, absolutely amazing. I really encourage people to check it out, either as a platform to play with, or as a platform, or just as something to look at. Just as something to look at for inspiration of how far we've come from the BBC Micro, its 32K of memory, to these machines which are so powerful that people who wouldn't consider themselves to be programmers can build amazing interactive experiences. So that's probably the coolest thing I've seen recently. So a lovely example, some of you may have seen, there's a new Unreal Engine demo.
Yeah, I did see the new Unreal.
It's a wonderful video. And somebody recreated one of the scenes from that in Dreams in an hour.
Wow.
It's really quite an interesting demonstration of how where we've got to, of where
Yeah.
40, 50 years of development of home computers.
Yeah, and on a console machine too, which is not like the be all and end all of powerful machines as well. Like that's super cool.
And also on the console, which kind of in my mind, consoles are slightly the enemy. When we talk about the history of Raspberry Pi, we talk about this BBC Micros being replaced by Mega Drives, Sega Genesis, Super Nintendo, Super Famicom, and that being the moment where everything closed down, when you went from the machine you buy to play games on being a general purpose computer to the machine you buy for games being a machine that's designed to be closed. So it's kind of nice, and I think Sony have got a real history of this actually, all the way back as far as the Euroxy development kit for PlayStation 1. They've had a history of this sort of thing, of trying to give people a little bit more access to the guts of these powerful devices that's been typical.
Yeah. And so, the power in the sense that you've got the processors, the RAM that you need on your machine. Like young people may not particularly understand what we mean when we talk about like 8 gig of RAM in the new Raspberry Pi. Could you explain to them in your particular idiom, like what that sort of means? What does it enable to have, the extra RAM on your machine and things like that?
Well, I'll start with the retro geekiness, which is
perfect.
Every bit, so your bit of memory is the basic element of memory stores a 1 or a 0. For every bit in the memory of so BBC Micro had 32K kilobytes of memory. That's a quarter of a million, so multiply by 8. So that's a quarter of a million bits. For every bit in the memory of the BBC Micro, our 8 gig Raspberry Pi has a BBC Micro's worth of memory. So each of those bits has now become 32K. And so we squared the number of bits. And that's just a staggering. And on the BBC Micro, the memory bit of the board was that sort of size. And on our product, the memory was this little signature. So it's a vast amount of memory. What does it let you do? Well, there are a lot of actually just using a computer as a general purpose computer, opening all the tabs in Chromium is an extremely expensive operation in terms of memory. So it certainly does extend our story about Raspberry Pi being a general purpose desktop computer. But there are a bunch of applications, sort of database applications, compiling big pieces of software, running large machine learning models, doing things like AI, doing image processing, where you actually do find that, even the 4 gig, which was our previous limit, you do actually end up blowing past 4 gig. So there is real utility, I think, as well, on the kind of the serious side, the engineering side of Raspberry Pi.
That's cool. That's really cool. Yeah, and that's one thing that we've been playing with on some of the Astro Pi projects with the machine learning type things as well. And that'll make that a lot more powerful, a lot smoother to run those sorts of things with heavy RAM. So that's really cool. Last question from me, and then I'll bring on Ed because his questions are incredible. But what advice would you, Eben Upton, inventor of the Raspberry Pi, have for young people who want to learn to code today?
Keep going, I think. It's really easy to get discouraged. I think it's less easy, actually. Once you got over the first barrier of your PC does not ship with a programming language, it's actually not so easy to get discouraged because you have access to this larger group of people who might support you or people who might watch what you're doing. But don't get discouraged. There's always, in my career as a child learning to program, and then in my adult career, and in the bit of my career where I was trying to make Raspberry Pi happen, it was very, very easy to get discouraged. There was probably 6 years between the idea of Raspberry Pi in my mind and us having something that we were shipping in the field. And I got so discouraged 4 or 5 times during that period that I completely stopped doing anything on Raspberry Pi. And I was very lucky to have my wife and my parents and my sister and other members of my family kind of rallied round. Every time I started to get distracted and go do something else, and hey, you go back and do that. Go back and do the Raspberry Pi thing. That was the thing. Go and do that thing. So kind of don't get discouraged. Find ways to not get discouraged. So figure out what's going on in your mind that's making you discouraged. Surround yourself with people who will encourage you, who will look appreciatively and supportively at what you're doing. It's programming computers is it's simultaneously easy and hard. Anyone can learn it, but it also requires focus over quite long periods in order to accomplish stuff. And it's funny. It's all about mental hacks. It's all about finding how to hack your own mentality, I think, in order to keep yourself going.
Definitely, yeah, I totally agree with that. One thing I like to say to young people is that you need to find the power inherent in it for yourself. Like, what is it that empowers you, and what is your hook to doing this? It's not a means to an end; it's an end in
Yeah.
itself, right? If you gain power for yourself, then that's incredible, and I think that's
Yeah.
awesome. Thanks, Eben.
And that's just like, you know, the one of the reasons why we think computing, you know, it was always this fear when we did Raspberry Pi that computing had its moment, and that 1980s was the moment, and that we were going to be shouting into the void. And I think there are lots of reasons why computing is still relevant and is still exciting for young people. But the power is one of the, you don't have a vast amount of power when you're young. You don't have an enormous amount of control over. There are lots of elements of your life where you just got to go to school, say you just got to do what you're told, right? But there is this little world. It was so valuable for me as a child that there is this little world inside the computer where you have all of the power, you know, and you have the power. It's inside the computer, so you can take the power out of the computer and use it to go do something in your daily life that you care about. And it sounds slightly crazed, right? It sounds like slightly mad scientist, but it is a thing. And I think it's very important. It's very exciting. And it's the reason why, where we had 1 or 2% of people doing computing when I was a kid, we've now got, you know, tens of percent of people doing interesting stuff on computing.
Yeah, and that's the amazing thing about the Pi too. Like, it brought that out, right? The idea that you have this machine that then you have actual applications in the real world. You know, in a short amount of code, you can be building machines, building gadgets, making robots, creating video games. It does everything. It's the Swiss Army knife. It's incredible. So I think there are millions of people around the world who are incredibly grateful you didn't give up, Eben. Like, I know I am. Like, I love using my Pi. I've got one out like multiple times a day, doing all sorts of different stuff. I've got them embedded in my house. They're everywhere. I think you're changing the world with the machine.
It's great, right?
It's great. That's amazing.
I mean, thousands of people. I'm thinking the thing is, thousands of people are changing the world. That's the lovely thing about Pi, is we built this organization. What are we? We're 200 people now across Raspberry Pi Foundation and trading. We've got about 200 people who are actually employed by Raspberry Pi. But you have, for every one person who's employed, you have 10, you have 100 people out in the community running clubs, you know, making this thing happen. It's been a wonderful thing to be part of.
Absolutely, yeah, 100% agree. So on that note, I'm going to bring in Ed, who's in Manchester at the minute. So Ed's got some questions for you. He loves the Pi. He's a coder. He's making all sorts of cool stuff. So Ed, did you have some questions you'd like to ask Eben while we're online?
Yeah, I have 6 questions for him.
None of which I have been pre-briefed on. It's an important lesson. I may regret my boldness.
So the first question is, I'm starting high school in September. What did you find best about high school?
The thing I found best about high school was that there were more people there, and so the things that I found interesting, there were more. It improved the odds that there would be somebody else who found the same thing interesting. And for me, that was computers, but it was true for people who were interested in building model trains and, you know, running up hills and, you know, jumping off hills and things. So there's just more people improves your chance of having an affinity group. That's what I think is exciting about it.
Okay. Is it true your computers are in space, and did they get photos of SpaceX?
Oh, I bet they didn't actually. So yes, they are in space. So we have two. We have 2 Astro Pi units. These are Raspberry Pis, $35 computers inside $3,000 aerospace grade aluminium boxes on the International Space Station. So we have those up there. There are actually other Raspberry Pis on the ISS at any given time, because it's a Swiss Army knife, and a lot of other people designing experiments need a computing element to their experiment. And so sometimes we only hear that there's been a Raspberry Pi on the station when it's come back. But there are probably more. I suspect although they have cameras, I suspect neither of them got a picture of Crew Dragon. But it's been an amazing few days for people who find space interesting, right? It looks like a machine from the future. It's incredible. Docked on the side of the space station. Looks like something from 2100 docked onto a thing from 1950. It's incredible.
What's your favorite coding language?
Okay, I'm going to pick something deliberately esoteric. 6502 assembly language, which is the assembly language of the BBC Micro. It's the 8-bit machine code that the BBC Micro runs. Why do I like it? I like it because it's like a Spears board game, an afternoon to learn, a lifetime to master. It's one of those things. What I quite like doing is writing programs and squeezing them to make them faster or smaller. There's a thing that, I don't know if you've seen this, it's worth checking out. There's a thing on Twitter, an account on Twitter called BBC Microbot, which you can tweet it a program in BBC Basic, and it will then tweet you back a video of the result of that program running on the BBC Micro emulator. And so I've occasionally done BBC Basic or 6502 machine code programs for that. It's such a massive geek. But it's great though. I mean, it really is, and it's simple. Most of my day-to-day programming, I don't do a vast amount of day-to-day programming at the moment because I'm busy running Raspberry Pi. But most of my day-to-day programming is either in C or in Python.
If you had £1, what sweets would you buy?
Oh, what would I buy? I would probably buy fruit pastels. Fruit pastels. That's my love fruit pastels. But partly because you can't really buy the kind of quite the little rubbish paper bag of sweets of my child, mixed sweets of my childhood, which you get boiled sweets and they'd last a long time per unit cash. But yeah, fruit pastels. How about you?
Well, I'm vegetarian, so I'd have to get something vegetarian, like probably like Maltesers.
Okay, so you couldn't have fruit pastels, right? Because they have gelatin.
Yeah.
And that's good. That does cut down your options. Maltesers. I like Maltesers.
Do you have Raspberry Pis everywhere?
Yeah, I have a lot of Raspberry Pis. They tend to be. I tend to have unreleased Raspberry Pis, so I tend to have secret toys. So I've had an 8 gig Raspberry Pi for a little while. Yeah, they tend to dangle off the. What I tend to do with most of the ones I have, I'm not so adventurous in terms of doing physical stuff. I'm really a software engineer. So I'm not so adventurous in doing physical stuff with my Raspberry Pi. So what I tend to do is I use them where some people might spin up a new virtual machine, a new Linux VM on their desktop computer. I tend to just get another Raspberry Pi out of the box and plug it in. So if you look at my home hub at home, my router, it has a bunch of Raspberry Pis dangling off the back on little short Ethernet patch cables dangling off the back. And every time I need a new Linux VM, I get a new physical bare metal piece of hardware. But yeah, it's kind of a museum of historical Raspberry Pis because I always get whatever the nicest one is and plug that one in.
Okay. And now the last question. How did you celebrate when you finished building the Raspberry Pi?
When we finished, well, we kind of haven't finished building the Raspberry Pi, right? Because we're always building the next one. But the first one, I remember when we launched the Raspberry Pi. So the 29th, we launched on the 29th of February 2012, which was completely. How did that even happen? How did we end up launching on the leap day? But we went to the pub. So we launched at about 7 a.m. UK time, I think, and then I was up, and then at 7 p.m. we sort of called it a day. We'd sold about 100,000 Raspberry Pis in a day. We knocked over the websites of both of our partners repeatedly. It was just their websites were up and down all day long. And during the little, if you add together all the little up windows, we did 100,000 in that little window of time. And we rented a room in the back of a pub in the middle of Cambridge. And a bunch of us. I mean, it's interesting that even then it was very, very small number of us involved compared to what we are now. But even so, even then we were able just to get Raspberry Pi 1 out of the door took enough people to fill a big room at a pub. Give you an idea though, Raspberry Pi 4, I always write a credits. If you go and look at any of the launch posts of Raspberry Pi products, I always write a credits list for all the people who worked on it. The Raspberry Pi 4 credits list from June of last year had over 400 people on it before I even started putting people who work for Raspberry Pi on the list. So we would need a very large pub indeed to celebrate Raspberry Pi.
Okay. Thank you.
That was cool.
No, thank you.
That was great, Ed. That's some great questions. Thanks for that, Eben. Thanks for your time today, mate.
I'm going to go buy some fruit pastels.
Same as me. I've got to get some sweets after this stream now.
Yeah, awesome. Well, thank you again.
No, thank you. I understand how busy you are with everything going on. So thanks for popping in, Eben. We'll see you again later, I hope.
Yeah, enjoy it.
Catch you later.
Cheers, guys.
Bye.
That was great, Ed, man. That was really cool. Thanks for asking those questions. I think you really enjoyed answering those. I'm sure they're not the usual kinds of questions that he gets asked, or most of the time when he does interviews and stuff like that. People tend to ask him lots of technical, boring questions rather than interesting questions about sweets and things like that. So well done, man. That was excellent. So should we crack on with your project? Because I'm really excited to show everybody the art project that you came up with this week, the really, really cool one. It's like, do you want to tell everyone what it's based on, like how you came up with the idea for it? Because it's a super cool idea.
Well, we kind of came up with the idea like, it's like the game where someone draws a head and then they pass it on to the second person and they like do the body and then they pass it on to the third person for them to draw the legs. And at the end, you kind of get a crazy character. So it's kind of like you're going to be drawing the head and it's going to random one of 6 sprites from the sprites list, and you're going to draw the head, but like it can be like whatever you want. It don't have to match the sprite's body and sprite's legs of what it comes up with.
That's cool. I remember playing a game like that when you draw the pictures. And there's another one where you can do it with words, right? Called Consequences, where someone like writes a sentence and then folds it over and someone else writes them, and you do it with a story. But today we're doing it with a picture to make like a character, which I think is super duper cool. So we've got a starter project for everybody. If you wanted to jump across, you can grab the Scratch project that's available now on Scratch. So you can just go to rpf.io/dm-art and you can see the project that Ed knocked up for us. So there's a starter there if you want to go across. I'm just going to share my screen because Ed's going to drive for today. And I'm going to, let's see, where's my sharing? I'm going to share my screen here. Hang on a second. Sorry, everybody, just give me 1 sec. Okay. All right, so we've got our starter screen here. This is our start project. So you should be able to get to this by going to dm-art. And once you've done that, you can just click remix and you'll get the project brought up here like this. And it will have this whole new project here for you available with all these different sprites and things in it so that you can use that. That should be available to you to get hold of. So if you just head across and do that now, that should be easy enough to do. And what we'll do, Ed, is if you want to start explaining to me where I should kick off with getting this project going, that would be amazing. What should I do first?
Well, first we're going to do the pencil code to be able to draw the head. So at the bottom right corner, you'll see that there's a pencil sprite. Could you click on that, please?
Totally can, yep. And so I know that I've got my pencil sprite selected because there's a picture of it here in my workspace at the top right of my workspace. So that's how I know it's right.
Yeah, and then we need to add an extension. And what we're going to do is add a pen extension. So the bottom left corner, you'll see a square that when you hover over it, it'll say add extension. If you could click on that.
Yeah, no problems.
And
then
then
I want the pen.
Yeah, the pen.
Aha, a whole bunch of new blocks popped in. Fantastic.
So now that we've got the pen ready, from event, we would want to get a when flag clicked block.
Cool. Got one of them.
Okay, and from motion, you'll want to get a go to random position and click the arrow and change it to go to mouse pointer.
Yep, all good. Got that one there.
And from pen, you'll want an erase all block, a pen up,
yep.
A set pen size to 3. Well, set pen size 2.
Yeah, so I'll pull that one across and I'll change set pen color. Oh no, I've got the wrong block. Hang on a second. Set pen size. Cool, I got it. I'm on it.
Change 1 to 3.
Okay.
Okay, and then you want a set pen color 2. And you can change the color to whatever color you want the pencil to draw as.
Cool. I think I'll choose that royal purple.
Okay. So now we're going to want to make it draw when we press the mouse button. So we'll need a control from a forever loop from control.
Yeah, no probs. I'll plug one of them in right there.
Still in control, we will want an if-then block.
Yeah, no problem. Got one of them and a couple of nested loops.
From operators, we'll want a not block.
Not. Yeah, cool. So we've got there we go, gem-shaped not block.
We will want from sensing a touching block. And we'll want to change it to touching button 2.
Okay, so as long as it's not touching the generate button we have on there, then it will have this code run. That's clever. I like that. Yep.
This is so that it doesn't draw when we want to click the generate button.
Yeah. That's clever.
From motion, we'll want to get another go to random position, and we'll want to change it again to mouse pointer.
See, cool.
From control, we'll want an if then else just under the go to mouse pointer.
Just like that, inside my if, like that. So if go to and then an if inside.
Yeah.
Cool.
We will want from sensing and mouse down, we will want to put it in the if then part of the block.
Yep, cool. I got one of them. So if mouse down, then
from pen, we want a pen down in the top part of the if block, and we'll want a pen up in the else part of the if block.
Cool. So as long as my mouse button is down, the pen will be down, and then if I let go, the pen will come up. So I'm not drawing anymore.
Yeah.
Cool. I get that.
Now what you will want to do is go into full screen and test it.
Okay, so I click the little expander to make it go full screen, and I click here, and then I can draw. Cool. It's working. I like it.
Now what we'll want is a quick way to erase it all. So from events, we will need a when space key pressed.
Yep, cool. Got one of them.
From pen, we'll need an erase